Very good evening, my dear children. Welcome to my class. And this is Suma with you, waiting for enjoying and refreshing mathematics. And today we shall just continue with the last topic which was left over, that is sets. We were talking about sets, you remember? So what is a set? A set is a well-defined collection of objects, which I had told you in the previous class. And I had given you an example of collection of books. Fine? And also the representation of sets. Basically, we have two types of representation. One is the roster form and another is the set builder form. The roster form, which I had told you, is all about the hard working. That is, you have to write the numbers and in a particular set. And in set builder form, it is all about simplifying and doing some kind of like smart work. And I had given you an example also in the previous class. Today we shall discuss types of sets. Types of sets. Before going to the types of sets, we shall know what is the cardinality of a set. What is meant by a cardinality of a set? I'll just take a set. Set is always represented with a capital letter enclosed with the flower bracket. For example, if I just take this, the cardinality of the set A is 1, 2, 3, 4. So what does it mean? The cardinality is the number of elements in a set. It's nothing but a cardinality of a set. With this, we shall discuss with the types of sets. So first type of set is an empty set. What is an empty set? A set which doesn't have any elements at all is known as an empty set. A set which does not contain any element. This can be written as this form, or you can just go for the nullify. So empty set is also called as a void set or empty set. Example, we will just discuss with an example. I'll just take an example. Even numbers, set of natural even numbers or even natural numbers which are divided by 3. So set of even natural number which is divisible by 3. Can we find any even natural number which is divisible by 3? What are natural numbers? Natural numbers are what? 1, 2, 3, 4, so on. 5, 6 and so on. 2 is an even number. Over here there will be formation of 2 symmetrics and 1. 4 is an even number. If I just take a natural number only till here, only till 4. If I want to divide this natural number by 3, even natural number by 3, will I be able to divide this by 3? So it's impossible for me to divide this by 3 because here the even natural number, it's 2 and 4 in this set. I am comprising my set. If you just take even natural numbers which is divisible by 3, you will get 6. 6 is actually divisible by 3. So I am confining my study only till here, till 4. So what can you have here? I can really have, there is no even natural number which is divisible by 3. Hence, what is a set? The set is a nullify. The set is an empty set. Now, after this, we just got to know what is an empty set. The next concept is singleton set. What is a singleton set? For example, I'll just take example of even prime number. So what are the even prime number? Actually the number which is not divisible by any other number which except itself. So here 2 3, 5, 7. So these are the numbers which are called as prime numbers. In this prime number, we will be having 2 as an even number here. Till 10, if I just consider, 2 will be an even prime number. So A is equal to 2. Prime numbers are what? Prime numbers are 2, 3, 5, 7. If I just consider till 10, 8 is not possible, 8 is divided, 9 is divided by the numbers, even 10 is divided by the numbers. I will just enclose it till, if I just consider the limit till 10. So here, which is the prime number here among this list? 2 is the even prime number. So this is only one element we can find out. Since we can find only one element, it is nothing but a singleton set. If there is only one element in the set, it is called as a singleton set. Then after this, we will just go for finite set. Finite set and infinite set. Finite set and infinite set. The name itself says, when we are able to count the number of elements in a set, it is a finite set. If we are not able to count the number of elements in a set, it's an infinite set. For example, I'll just ask you to count the number of stars in the sky. Will you be able to count? It's impossible. So for the whole day, for the whole year, for whole of your life, if you keep counting, it's impossible to count. So that is why that is called as an infinite set. And for example, the representation like this. If I just write the numbers like this, and if I just go for writing the numbers like this, so on. Which is a finite set in this? A, because I have stopped till 5, where I will be able to count. How many elements are there? 1, 2, 3, 4, 5. There are 5 elements in this. Now here coming to this, how many elements are there in this? 1, 2, 3, 4, 5 and so on. Till where it has stopped? We don't know. So this is called as an infinite set, and this is called as a finite set. So we spoke about an empty set, we spoke about a singleton set, we spoke about a finite and infinite set. Now the next discussion is about equal sets. Equal sets. What is meant by an equal set? If two sets, always equals will have to go with 2 sets minimum. If I want to take an equal set, if I just consider 2 sets A and B, then it should have the same number of elements and the elements must be identical. Elements must be the same, or you need to have the identical elements here. So for example, if I just take A is, or the set A, X, where X is a word, wolf. Now I'll just take a set B, so Y, OW, follow. I have just taken A as wolf, I have just taken B as follow. Now I just want to write down the set. I don't consider this initially as a set here. To make you people understand, I have just taken it here. I want to write a set for this and I want to write a set for this. What do? I'll just take A. What is the set? What are the elements that we have in this particular thing? W, O, L, F. What are the elements that we have for this? I'll just consider that set is B. I have F. I have O. O is repeated twice, but it is not said that in a set you should repeat the elements. Though you have two elements here, two repeated elements O and O, but you are supposed to write only one single O. Then I have L. Then I have W. L is also repeated twice, but will not be considering two letters of L here. Will be taking only one L. So what is this? F, O, L, W. Do we have F here in the first set? Yes. Do we have L? Yes. Do we have O? Yes. Do we have W? Yes. So how many elements are there in the set? 1, 2, 3, 4. And how many elements are there in the set? 1, 2, 3, 4. So there are 4 elements. Even here we have 4 elements. Do we have the same letters, same elements? Yes, we have the same elements. Then can I call it as an equal set? Yes, you can call this as an equal sets. This is called as an equal sets. Now, my next understanding or my next extension of this equal set is an equivalent set. So what is meant by an equivalent set? It is also something, a part of it is connected to the equal sets. That is equivalent. What is meant by an equivalent set? I'll just take an example. 1, 2, 3. B is equal to Jan, February, March. I am actually taking these two sets. What can I say with the equivalent sets? I should have the same number of elements. The number of elements must be the same. And it's not mandatory that you need to have the same elements for the set B also. So here I have 1, 2, 3. There are 3. What is the cardinality of this set? It is 3. Now coming to this B. What is the cardinality of the set B? Yes, it is 1, 2, 3. But do we have the same elements here? We have a number and we have the month. So this type of set are called as an equivalent set. So we spoke about an empty set or a void set, singleton set, finite and infinite set, and equal sets and equivalent sets. Now the very important and a special kind of set is subsets. This is very, very important. Subset, where if I just consider two sets A and B, if I just consider two sets A and B, if every element of A is a part of B or it is contained in B, we just call such sets as subsets. For example, I have A is equal to 1, 2, 3. B is equal to, I have 2, 1, 2, 3, 4, 5, 6. What can I say now? This A is a part of B. When we use the word part, it obviously says that A is contained in B. So we can clearly say that A is a subset of B. This is called as a superset. This is called as a subset. This is called as a subset. This is called as the parent set, or a bigger set is called as the superset. Now there was a confusion. When we just spoke about a subset, when we have this kind, we can easily say that it is a subset. But there was a lot of confusion. Why? Because if I have 1, 2, 3. Now if I have 1, 2, 3 as well here, can I write again A is a subset of B? Yes, I can write A is a subset of B. But why then the question arises, can it be called as an equal set? Yes, you can call it as an equal set. You have 1, 2, 3, you have 1, 2, 3, the cardinality of A is 3 and the cardinality of B is also 3. That is why the concept of proper subset was established here. What is meant by a proper subset? In the proper subset, we will be taking off this equality here. What is meant by a proper subset? If A is contained in B and A is not equal to B, what does it say? Can we call this set as a proper set? No. This can be called as a proper set. Why? Because cardinality of A is what? 3. Cardinality of B is what? 6. Is A equal to B? No. When A is not equal to B, we just call this as a proper subset. Now, we have spoke about a subset. What is a subset? And we got to know what is a subset as well and what is a proper subset. So, this is all about a subset. And because of this, we could say that every set, every subset or every set is a subset of itself. Every set is a subset of itself because here I have 1, 2, 3. So, this can be a subset of itself. This can be a subset of itself. So, what do we understand? Every set is a subset of itself. Now, I will just take 1, 2, 3. So, can I say it as a subset? Yes, because what is this? What is the statement that we have? Every subset is a subset, every set is a subset of itself. These are the things which we can understand with the concept of subsets. And the next thing is power set. What is a power set? The subsets of all set is a power set. These are subsets of all the set. For example, I will just take A is equal to 1, 2, 3. And here I will just write the power set. P of A, I will just take P of A. What is P of A? And here one more thing, when we are writing the subset, empty set is also a subset. So, we need to be very clear. I have an empty set here. Empty set is also a subset. And first I will just go with the singleton sets. How many subsets can be formed with this set? It is singleton. I will go with singleton sets. I will go with the combination of this. So, it is 1, 2, then 1, 3, 2, 3, then I will just go with, since I have finished off with this 2 elements of the set here, so I will now go with 3 elements. So, how many elements you can actually have? It is 1, 2, 3, 4, 5, 6, 7, 8. With this 3, I have got 8 subsets. When these subsets are put together, we just call it as a power set. And there is a formula for the power set as well. So, that is P of A is equal to 2 to the power of n. 2 to the power of n. So, n it's nothing but how many elements are there? 1, 2, 3 elements are there. So can I just take it as 2 to the power of 3? What is 2 to the power of 3? It is nothing but 8. 2 to the power of 3 is what? It's 8. Do we have 8 elements? Shall we have a look at this? 1, 2, 3, 4, 5, 6, 7, 8. Yes, we have 8 elements under this. So this is nothing but a power set. And the last part is universal set. It is nothing but the union of all the sets. It is the mother. It is the mother of all the sets, universal set. We just consider all the sets here. It is universal set. So we spoke about an empty set. We spoke about a singleton set. We spoke about an infinite and finite sets as well. And we spoke about subsets. We spoke about unequal sets and equivalent sets, and we saw with few of the examples as well. Fine. I hope you clearly understood this, and in the next class we will be discussing with few problems on this, and let me wind up the class, and I hope you all enjoyed the class. Always have a track on this class. Thank you.